Hi, this is Melinda Ruff, and this is my final screencast for Atmospheric Science 101. We'll start off today's screencast with a discussion of temperature and how it is affected by solar altitude and snow and cloud cover in the winter and in March. So in Eagle, these spikes indicate the sun rising and setting. As we can see, it rises about 11:10:30 and sets right around 5-6 o'clock during the January and February week. This allows for limited solar radiation to affect Eagle during the January and February months. As we move on to the satellite pictures, we'll notice that there is a low system here on Sunday with two highs up in the northwest from Eagle. And then as we move down towards Thursday, that low got replaced by a high just over Eagle, which will bring with it clear skies and fair weather. But as many of us in Alaska know, usually the clear weather is the worst and the coldest. Because as the clouds decrease and cloud cover is no more, solar radiation is able to escape from the atmosphere, making it colder. Whereas with cloud cover, during the winter in Alaska, it can actually keep some of the heat inside and make for warmer days where you would normally expect colder days. So going back to the temperature, we can see that it was expected to be much warmer, but however was much colder instead. And this is accounted for by the high pressure system that moved in after Sunday. You can see that right here there was the low pressure system, and it kind of kept on par with where climatology said Eagle was supposed to be at. But once the high pressure systems moved in, that accounted for the lower temperatures. So in this case, we would definitely say that the warmer climatology versus the cold measurements we got was represented by the clear skies. So the clear skies made it colder than it was supposed to. If we had gotten a low pressure system and cloudy skies, we would have probably seen temperatures along the same lines as what climatology told us. Next, we'll move on to humidity and cloud cover. As you can see, our measurements in January and February were very sporadic and would not be terribly helpful in deciding whether cloud cover and humidity are related or could possibly be relative to one another. So we'll move on to March. As you can see, these measurements are much better for comparing cloud cover versus the dew point temperature and the relative humidity, which is the blue line. We'll start off by comparing Tuesday, March 24th, and Thursday, March 26th on the relative humidity percentage and the cloud cover. So on Tuesday, our relative humidity was up here about 68%, we'll say. 68% relative humidity. And it was much lower, about 30% earlier in the day. We'll go over to the satellite images, and you'll notice that there doesn't seem to be much cloud cover here on Tuesday, March 24th, and our water vapor does seem to be in the it's not quite as concentrated, so it does support the idea that there is not much cloud cover, because this one is the water vapor image, and you can see here that there doesn't appear to be much cloud cover over Eagle. So if on Tuesday it's 70% humidity without much cloud cover, we might expect that on Thursday this medium humidity percentage might call for some kind of cloud cover, maybe less cloud cover, or maybe even more cloud cover. Let's find out. On Thursday, you can see that there's a lot of cloud cover. You can see this portion right here is not very covered, and this instead is quite white. And then you can see here, it's a little what the wider versions, the wider colors on here are where water vapor is the most concentrated, and you can see here that it's kind of in the medium area with water vapor. And we'll look down at this time, and it's 3 o'clock. So if we look over at 3 o'clock, it says it was supposed to be about 50% with a lot of cloud cover. 50%, and there's a lot of cloud cover, whereas on Tuesday at 2 o'clock, which is when the images were taken, it was at about 68% with no cloud cover. This indicates that there's not really a big connection between cloud cover and humidity. Earlier I mentioned these high pressure systems that moved into Eagle in the later part of the week in January. And these highs moved in from Siberia, bringing cold temperatures and clear skies, which accounted for the lower than expected temperatures in Eagle during January. We'll move on to March and how it was warmer than expected temperatures. Here on Tuesday, we can see these two high pressure systems just barely to the east and southeast of Eagle, and then to the south of Eagle, there's this low pressure system in the Gulf of Alaska. On Thursday, we've got all those high pressure systems have been replaced by low pressure systems. There's lots of cloud cover, whereas earlier in the week there hadn't been as much cloud cover. And these low pressure systems are what we can account for the warmer than normal temperatures in March. As these low pressure systems move in and increase cloud cover, solar radiation and solar altitude have increased since January, bringing in more solar radiation and trapping it within the atmosphere underneath the cloud cover, making it warmer in Eagle than it would have been had there not been these heavy these low pressure systems moving in. And then we can see over here that this is a storm system that's moved in. There's lots of precipitation, and this is what has accounted for the warmer than average temperatures in Eagle. Normally, Eagle would have gotten clear skies, which would have helped melting, and maybe would have had it be a little bit cooler, but still clear skies and high pressure systems, whereas this year we got low pressure systems which kept some of the heat inside and maybe did help a little bit of the melting, but for the most part just storm systems and precipitation. Here's the temperature graph for March in Eagle, and as you can see they were much warmer, and these peaks are when the sun has risen, and if we can tell that these are much larger spikes than in January, where there was less solar altitude and where the sun wasn't up for as much time as it is in March now. So these helped. The solar altitude did help a little bit with the increased temperatures. However, the low pressure systems that moved in did help increase the temperature. As we can see that the pressure remains quite low throughout March, whereas once we look back to January and February, it was much higher, which coincides with the high pressure systems we saw move in and the low pressure systems that moved in. So there you have it. Hope you guys enjoyed it, and congratulations on finishing Atmospheric Science 101.